85 degrees north, a black lake in a white desert. This is the Nansen Basin Polynya, a scar of open water surrounded by thousands of miles of crushing pack ice. Here, the water is glassy, still, and deceptively void. But 40 meters beneath the hull of the USV Viscosity Prime, the silence is an engineering problem.
Bridge to deck 1, station keeping enabled. Dynamic thrusters at 4% load. GPS lock confirmed. Holding at 0.0 knots.
The Viscosity Prime is not a fishing trawler. It is a 300-meter fluid processing supertanker painted in surgical green. It has no nets, no cranes. It is a floating refinery designed for a single translucent target. The mission is fluid extraction. The target is an anomaly.
Unit Chief Foster here, initiating LIDAR sweep. Penetration depth 100 meters. We have a return. Large-scale density anomaly. Depth 50 meters. Cross-section is massive.
On the tactical display, it looks like a displacement of light. A translucent disk, 80 meters in diameter, hovering in the abyss. This is Cyanea titanis, the Titan lion's mane. To the naked eye, it looks like a giant contact lens floating in the dark. To the crew, it is a reservoir. 98% of this organism is seawater, but the remaining 2% is an aerospace-grade Cryo-Gel, a substance that maintains viscosity at temperatures that would shatter carbon steel.
Chief, relative velocity 0.2 knots. If we don't drop the Baric Dome in 60 seconds, we miss the centering window.
Below the waterline, the moon pool doors slide open, massive steel gates on the ship's belly. They are preparing to lower the Inverted Baric Dome, a 100-meter wide steel suction cup. If the vacuum seal is imperfect, the pressure differential will slice the specimen into useless ribbons. If it holds, we begin the most complex fluid transfer in maritime history. Dr. Alara Cross is at the monitors. To her, this isn't a ghost. It is a shivering slab of profit. The pumps are priming. The harvest is about to begin. Beneath your feet, the Viscosity Prime is hollowing itself out. Ambient water temperature, -1.8 degrees. At this temperature, the ocean isn't just cold. It is a high-density medium, nearly a gel itself. To stay on station, the dynamic positioning system fires subsurface thrusters in microbursts, fighting the lateral current.
Moon pool clear. Winch tension 12,000 kilograms per line. Starting the drop.
Now comes the dome. A 100-meter ring of stainless steel suspended by 16 hydraulic winches. It looks less like a tool and more like a cathedral ceiling being lowered into the abyss. You don't use nets here. A net would act like a cheese wire, slicing 80 meters of biomass into shredded pulp. The goal isn't to catch the Titan. It is to encapsulate the water column it occupies.
Chief Voss, descent rate locked. Monitoring pipe friction. We're seeing a viscosity spike. Keep us centered.
As the dome descends, displacement becomes the enemy. A steel cup this size creates a massive pressure wave. If that wave hits the jellyfish too hard, the specimen will disintegrate. It is a fragile ghost held together by surface tension.
Cross here, stress on the bell. Voss, you're pushing too much water. Slow the descent. If those cells rupture, the Cryo-Gel contaminates the intake.
The dome slows to a crawl. The friction of water against steel creates a low-frequency hum that vibrates through the hull. This is the soft seal. The edge of the dome is lined with a flexible polymer skirt. As it touches the water layer surrounding the jellyfish, the winches must balance the load. Contact. The dome has settled. The Titan is trapped within a closed steel system. But it isn't in the ship yet. It's just in the lobby. Next comes the lift. We have achieved the soft seal. Now the ship starts acting like a giant atmospheric pipette. You cannot pull a creature the size of a city block. It would fall apart under gravity. To bring the Titan into the hull, we don't lift it. We let the ocean push it.
Seal integrity 98%. Priming primary intake turbines. Watch the cavitation levels.
Inside the moon pool are 4 massive centrifugal pumps. When engaged, they evacuate the water from the top of the column, creating a low-pressure void. The ocean tries to fill that void instantly. It forces 80 meters of translucent biology upward, surging into the ship's internal dry dock at 3 meters per second.
Turbine 1 at full load. Flow rate 12,000 liters per second. I'm seeing the specimen move. It's entering the chamber. My God, it's like a mountain made of glass.
The sound is a deep, vibrating thrum. Thousands of gallons of Arctic water rushing through stainless steel pipes. Inside the moon pool, the Titan lion's mane rises out of the dark water like expanding dough. A building-sized lens of jelly, shivering as it is squeezed through the intake. It is perfectly clear, refracting the surgical green lights like a massive liquid diamond.
Specimen 70% clear. No ruptures. Transparency 99%. Voss, prep the airlock gates. We're about to go dry.
This is the capture paradox. To harvest the gel, we have to remove the water. As the last of the seawater is pumped away, the jelly is left suspended in the airlock, held in a cradle of polymer tension cables. 80 meters of shivering, translucent life. But we only want the top. The tentacles below are toxic waste. To get to the profit, we have to perform a perfect horizontal surgery. The water jet guillotines are sliding into position. The Titan is out of its element. Suspended in the airlock, it hangs like a ghost caught in a net of light. But we have reached the contamination window. At this scale, the creature's own biology is a threat.
Voss to processing. Weight 400 metric tons. We're seeing a gravity load on the lower filament forest. If we don't clear the waste, the internal pressure causes cellular collapse.
The jellyfish is 2 distinct chemical profiles. The top, the bell, is the reservoir. The bottom, the tentacles, is toxic debris. If a milligram of tentacle tissue enters the press, the harvest is rejected.
Cross here. Transparency at the limit. Chief, I need a clean shear. No friction, no heat. Use the hydrojets.
To solve the problem of a building-sized surgery, we use the water-jet guillotine. A ring of stainless steel emitters slides down the airlock walls. A steel edge would snag. Instead, we use the ocean against itself. Ultra-high pressure nozzles firing recycled seawater at Mach 3.
Aligning emitters. Pressure 30,000 psi. Standby for shear. Fire.
The sound is a high-frequency scream. A razor-thin sheet of water zips horizontally through the creature. It is a perfect separation. The weight of the tentacles does the rest. 100 tons of toxic filament fall away, sliding back through the moon pool and into the abyss. They vanish in seconds. What remains is the prize. A clean, shimmering cathedral of pure biomatter. But it is still 98% water. To extract the 2% that matters, we have to squeeze it until the cellular structure surrenders. The osmotic press is waiting. Look at the scale. You are standing on a gantry 40 feet above the processing floor. Below, the bell has been laid out across a white conveyor belt the size of a 6-lane highway. 400 metric tons of glacial slime. We have to get rid of the water.
Belt tension at 45 tons. Experiencing lateral slip. Increased vacuum pull. We need this thing flat.
The solution is the osmotic press. Standard squeegees would rupture the matrix. Instead, the bell passes under massive Teflon-coated rollers. These are precision instruments. They exert exactly enough pressure to force the seawater out while keeping the Cryo-Gel trapped inside.
Crosshair, refraction index shifting. Voss, the lead roller is too heavy. Back off hydraulic pressure. I want that gel clear, not milky.
That is the sound of the ocean leaving. A literal waterfall of brine cascades off the sides of the belt. Beneath the Teflon, the transformation is visceral. The jelly doesn't break, it densifies. It changes from a watery mass into a thick concentrate with the viscosity of corn syrup.
Volume reduction target reached. The 80-meter bell is down to a 20-meter slab. Density index 1.4. It's heavy, Chief. Moving to wire cutters.
We have achieved order from chaos. The building-sized creature has been compressed into a dense slab of aerospace-grade Cryo-Gel. It is no longer biological. It is raw industrial material. But a 20-meter slab is impossible to ship. To make it portable, we have to turn this liquid mountain into perfect stackable math. The grid of heated wires is descending. The slab is silent. 20 meters of concentrated matter sits stationary. It is too thick for a blade. To make this mountain portable, we impose a rigid geometry.
Induction coils hot. Wires at 500 degrees. Commencing descent.
Above the floor, a grid of tungsten alloy wires descends, glowing cherry red. At 500 degrees, the wire doesn't cut. It cauterizes. It melts through the protein chains. As the wires touch the surface, there is no resistance, only a low electronic hiss. The grid passes through the slab with the weight of a hydraulic press.
Cross here. Edges sealing perfectly. No leaching. The cellular wall is fused. Send in the arms.
The math is revealed. The ghost is gone, replaced by 2,000 1x1 m3. Translucent, vibrating bricks. Blocks of frozen Arctic moonlight. But each weighs 1,000 kilograms. The Viscosity Prime deploys its heavy lift articulators. 6-axis robotic arms swing over the belt. They use soft-touch vacuum grippers. A wet thwump as the gripper makes contact, followed by the hiss of vacuum pumps. We move to the deep silence of the hold. Look at them. A warehouse filled with shivering glass. Thousands of cubes stacked 10 high, stretching into the dim recesses. Each one reflects the clinical white LEDs, creating a flickering emerald hall of mirrors. This is the odd satisfaction of the harvest. We have taken the chaotic biology of the ocean and forced it into a perfect grid. Outside, the Nansen Basin is a violent desert, but in here, there is only geometry. The aerospace refineries are waiting. Mission complete. Turn the lights off. Subscribe the Pelagic Archives for more documentary.